change their shapes. Okay, that's something else. Now let's talk about what's inside of the galaxies. Now we've said, of course, there are just billions or millions of stars, but it turns out that there are different kinds of stars that are more prominent in some galaxies than in others. So in a spiral galaxy, all right, the star types is a mix of population 1 and population 2. Okay, now what does that mean? Now, I think we haven't talked about what a Pop 1 and a Population 2 star. Basically, the Population 1 stars are new stars, are younger stars, and Population 2 are older stars. Okay, so in spirals you kind of have a mix. Okay, and the interstellar content, okay, that's just the gases, is like 15%. Now, in elliptical, you tend to have only old stars, Population 2. So you very rarely find the blue stars. And in these elliptical galaxies, the interstellar content, that's the gases, is very low. And that actually kind of makes sense if you think about it, because the old stars, it's basically made up of old stars. And if you're made up of old stars, there's not many young stars. Well, the gas, the interstellar content, of course, is, well, that's the stuff that makes the stars, so the young stars. So it makes sense that these are basically, these are old, and these are kind of midlife. And the irregulars, you see lots of blue stars, which of course are new stars. And so you have lots of interstellar content, and therefore this is the youngest. Probably should have done this in a different order, but these are the youngest of the galaxies. The ellipticals are old; they're very old, and the spirals are kind of in their midlife. We in the Milky Way galaxy, where our star is one of these midlife deals. Okay, hey, let's talk about the cause of galaxy types. So what causes a galaxy to be a particular type? And so the idea is that spirals in general rotate relatively faster than ellipticals. So they move, the rotation is fast. Rotation speed of ellipticals is different, flattening shows. The point is, I guess, is the galaxies are changing from one type to the next. And it has to do with their rotation speeds, okay? All right. Now, another thought on how galaxies form is by other galaxies interacting with them as or colliding. So sometimes a galaxy will collide. So here's actually, let's take a look. This picture right here is a picture of a real galaxy. And it looks pretty cool right here, doesn't it? And so there's been some computer simulations done. These are not real pictures up here. The idea of we have two elliptical galaxies that come and they collide. So this is like, a particular year, 1 year. Actually, these are millions of years, whatever. And then picture 2, now they're about to collide. Picture 3, now we have this interaction. And then picture 4, and that looks a lot like this picture here. So they kind of backtracked and said, what could that come from back here? So that's kind of an idea, is that a lot of these galaxies could be caused by collisions. And there's pictures of galaxies colliding, and that's pretty cool up in space with telescopes and stuff. So what's the consequence of a collision? Well, individual stars are left unharmed. Now that seems odd. When you think of something colliding, you think of actually hitting each other. But they don't, because you see the stars are really, even though you have a galaxy, this is, right here, millions of stars or whatever, they're so separated. The stars are very, very far apart, even though it sort of doesn't look like that. They're very, very far apart. So they just pass right through each other, but because of all the gravity of all the other stars, it causes the shapes to change significantly. So, but you also have gas and dust clouds, and they would collide, and they would trigger the formation of many, many new stars. And then a small galaxy may alter the stellar orbits and create a new ring galaxy. So we can get all kinds of really cool stuff happening in these collisions. All right. Now, what is some evidence that proves that this is what causes galaxies to form and have different shapes? Okay, evidence for it is, on a large scale, small galaxies may be captured and absorbed by a large galaxy in a process called galactic cannibalism. Oh, I love that. Cannibalism, you get to eat yourself. We don't eat, well, not yourself, I guess you eat somebody else. But the galaxies eat each other, so to speak. And so the big one basically eats the little one. That's how it works. Okay, so I guess the point of this whole thing is that they're trying to figure out what causes a galaxy to have a particular shape, and one of the understanding is this collision, is that these galaxies are colliding, and there's this thing called cannibalism, where they cannibalize each other. So that's kind of the point of the second half. The first half, we were just categorizing our galaxies and trying to figure out exactly what causes the galaxies. So that said, I think it's time for us to take a pause and to go probably do a worksheet and some assignments, and you're going to categorize the galaxies and make them all the S's and the E's and the various varieties. So we will see you in classes.